Good morning, everybody. So today's topic is Bohr's model of hydrogen atom. In this module, you will learn about the Bohr's model of hydrogen atom through the study of atomic spectra of hydrogen. When white light passes through a prism, it bends and spread out into a series of color bands called spectrum. Such a spectrum, which consists of a band of all 7 colors of Gibbs, that is violet to red, is called continuous spectrum. If the white light passes through some absorbing material like cold gas, then the atom of gas absorbs the radiation of certain fixed wavelength, and the transmitted spectrum in this case have some dark line in place of color corresponding to the absorbed wavelength. Such a spectrum is called absorption spectrum. After absorbing, the radiation of atom of gas get excited. During excitation, a few electrons of atom jump higher energy level. When the electron come back to the ground energy level, the atom also return to the ground state. And during the ground state, transition energy is emitted in the form of radiation. The resultant spectrum of the emitted light contains some bright lines with dark space in between. The bright light lines correspond to the wavelength missing in the absorption spectrum of a gas. Such spectrum is called emission spectrum. Okay. Spectrum is called emission spectrum. And adding the emission and absorption spectrum of one element, a continuous spectrum is obtained, that is known as continuous spectrum. Hydrogen and all other elements have the unique and emission spectrum. The Swedish scientist John Rydberg noted that all the series of lines of hydrogen spectrum can be described by the expression mu equals to 1.09677 into 1 upon n1 square minus 1 upon n2 square, where n1 equals to 1, 2, 3 and so on, and n2 equals to n1 plus 1, n1 plus 2 and so on. In this spectrum of hydrogen, the first 5 series of spectrum line that correspond to n equals to n1, 2, 3, 4, 5 are known as Lyman, Balmer, Paschen, Brackett and Funt series respectively. Niels Bohr, a Swedish physicist, was first explained quantitatively the general feature of the structure of hydrogen atom and its spectrum. In his postulates, the electron in hydrogen atom can move around the nucleus in a circular path of a fixed radius and energy, and these paths are called orbits. And these orbits are arranged concentrically around the nucleus, and the energy of electron in orbit does not change with time. And the electron will move from lower stationary state to higher stationary state when required amount of energy is absorbed by the electron or energy is emitted, or when electron move from higher energy state to lower energy state. The frequency of radiation absorbed or emitted when transition occur between two stationary states that differ in energy by delta E, that is formulated by mu equals to delta E upon H, or delta U you can write E2 minus E1 upon H, where mu equals V equals to frequency, E2 equals to energy of higher energy level, E1 equals to energy of lower energy level, and H equals to Planck constant. And this expression is commonly known as Bohr's frequency rule. Is it? Next, the angular momentum of electron is quantized and given stationary state. It can be expressed as equation mvr equals to n multiplied by h upon 2 pi r. mvr, is it? Where m equals to mass of electron, v equals to velocity of electron, r equals to radius of energy level, h equals to Planck constant, and n equals to 1, 2, 3, and so on. However, according to Bohr's theory for hydrogen atom, the stationary state for electron are numbered n equals to 1, 2, 3. These integral numbers are also known as principal quantum number, that is formulated as Rn equals to n square alpha 0, where n equals to principal quantum number and A0 equals to 52.9 picometer. The most important property associated with the electron is the energy of its stationary state. It's given by En equals to minus RH multiplied by 1 upon n square, where n equals to principal quantum number and RH equals to Rydberg constant. That is 2.18 into 10 to the power minus 18 joule. The energy of lowest state, also called the ground state. Delta equals to as E1 So these postulates explain for the hydrogen atom, and Bohr's model only explain lithium plus 2 ion and beryllium plus 2. So Bohr's theory failed to explain the structure of atom with more than one electron. So in this module, you have learnt when white light passes through prism, continuous color bands are obtained. If before passing through prism, the white light passes through some absorbing material, radiation emitted by excited The radiation emitted by the excited sample produced the spectrum called emission spectrum. And the first 5 series of special line of hydrogen spectrum are named as Lyman, Balmer, Paschen, Brackett, and Pfund series. Niels Bohr explained the structure of spectrum of hydrogen atom. Bohr suggested that electron in hydrogen atom revolve around the nucleus in orbit with fixed radius and energy. So each energy level or orbits correspond to a particular value of principal quantum number, where n has a value 1, 2, 3, and so on. Energy is absorbed when electrons move from lower to higher energy level, while energy is emitted when electron moves from higher to lower energy level. So Bohr's theory is applicable to the ion containing only one electron like lithium plus 2 and beryllium plus 3, but it could not be explained the structure of atom containing more than one electrons. That's all. Thank you. Have a nice day.